These are the homework answers to pages 432 to 434, Unit 12, Lesson 6, Mixed Probabilities. Number 1, the probability of S and I is 0.40, and no, they are not independent. Number 2, the probability of S and M is 108 over 1,376, or a decimal equivalent, which is 0.0785. Number 3 is choice 1. Number 4, the probability of P given K is 82.6%. It is 82.6% likely that a student in Key Club is also in AP Physics. Number 5, the probability of A and T is equal to 0.61. 5B, no, they are not independent. Number 6, it is more likely that the probability they jog given both siblings jog. So the probability of jogs given one sibling jogs is this 0.186 approximately, and the probability of jogs given both siblings jogs is approximately 0.225. So this one is greater, more likely. Number 7. Yes, A and B are independent. Number 8, A1, 0.946, 2, 0.352, 3, 0.158. Number 8B, the probability of bruised given ripe is greater than probability of bruised. This tells us that ripe avocados are more likely to be bruised than avocados in general. 8C, they are not independent. And D, the probability of bruised given not ripe is 0.040. Okay, explanations. So back to number 1. If you use the Venn diagram, so you wanted to find the probability of S and I. So what's in purple, what was given to us, or no, this 0.20 was neither, that they would agree on neither. So that's outside of the two circles. So that means our OR here would be 1 minus 0.20, which is 0.80. And then if this altogether is 0.80 and this all of circle I was 0.7, then that means that this portion of S would have to be 0.10. And if that's 0.10, then this has to be 0.40. so that all of circle S would total 0.5. Independent if probability of S and I equals probability of S times the probability of I, 0.40 does not equal 0.35. So no, they're not independent. The other thing is if you did a table, right, instead of a Venn diagram, you have S, not S, total, I, not I, total, and filled in, so the blue is what was kind of given to us. I, total was 0.7, S, 0.5, and not I nor S was 0.20. And then the lower right-hand corner here has to be 1, total 1. So, and the tables are very nice, actually. So then we can get 0.7 plus 0.30 would bring us to 1. 0.5 plus 0.5 would bring us to 1. If this is 0.20, then this has to be 0.30 because 0.3 plus 0.2 would bring us to 0.5. And if this is 0.7 and this is 0.3, then this needs to be 0.4. And then the probability of S and I is right here, S and I is going to be 0.4. And then the same equation to test for independence. Number 2, either using the Venn diagram like I did, or using the formula is still going to get you the same fractional value for the probability of S and M. Or let me show you the they use the table. S not S total, M not M total. Total S was 649. Total M was 433. The lower right-hand corner is the total number of students, which was 1,376. So then we still have to find this piece right here. So I did end up using the formula, right? The probability of S or M was the 974 over 1,376. That was given to us. So the number in S or M would equal the number in S plus the number in M minus the number of S and M. Right? So this or, if I'm looking at the table, is going to be, it's this plus this plus this, but then you have to subtract out this because it would have been counted twice. All right. But that's what we needed to find. So the 974 is equal to the 649 plus the 433 minus the number of S and M. Combined there and then subtracted that, you get a negative 108 equals negative number of S and M. So divide by negative 1 and the number of S and M is 108. So change that to a probability by putting the 108 over the total 1,376. Number 3, the probability of over 50 given the age of 23 to 60 So we're looking at just the age group of 23 to 60. We need the total there, which is 229. That's our denominator. And then out of those 229, how many were over 50 text messages? And that was 157. So 157 over 229. Number 4, again, probability of P given K came out to be that. So it's a probability of P and K, which was the 0.019 was in both, over the probability of K, which was the 0.023, changing the percent to decimal. Number 5, either Venn diagram or the table. I'll just explain the table here. So we have a hypothetical 1,000. A for adult, not A. Total, T for traveled, not T. Total. And the purple is what was given, 78% traveled outside, so 780 was a total for T. 72%, 720 the total for A. And 11% did not travel outside the state. 11% are adults who have not. So adults who have not traveled, so that would be A and not T. So this box right here would be 110. And then easily filling in the other cells of the table, because the lower right is 1,000. So 720 plus 280 brings us to 1,000. 780 plus 220 brings us to 1,000. 110 plus 110 brings us to 220. 610 plus 110 is 720. And the 170 plus 110 brings us to the 280. So the probability of A and T is this 610 over 1,000. Independent if the probability of A and T equals probability A times the probability of T. That's not a plus, that should be a times. 0.61 does not equal 0.5616, so no, they are not independent. Number 6, probability of the student jogs, given that one other sibling jogs, is the total for the denominator, which is 2,239. Yeah, you had to put the totals in here. And jogs 416, which is equivalent to this decimal. And probability of jogs given both siblings jog. So denominator is both siblings jog. And 400 is the numerator, which is this decimal, which is greater. Number 7, using the formula, determine whether A and B are independent or dependent. Well, we were given the probability of A and the probability of B. We first had to find what the probability of A and B is. So using the formula for probability of A or B equals probability of A plus probability of B equals minus the probability of A and B. And so kind of like what I did in the notes was, if I just add this to both sides and subtract that from both sides, you end up with the probability of A and B all by itself equals the probability of A plus the probability of B minus the probability of A or B. And then substituting in the 0.6, the 0.5, and then the 0.8. and you get 0.3. And then once you have that, then I use they're independent if the probability of A and B equals the probability of A times the probability of B. So 0.6 times 0.5 is 0.3. 0.3 does equal 0.3, so yes, they were independent. Number 8, probability not bruised. That's 1 minus the probability of bruised, and being bruised was 0.04, so it's 0.946. Probability of ripe given that it's bruised. Probability R given B is the probability of ripe and bruised, which was given, which was 0.019, divided by probability of bruise, 0.054. Then you get this decimal. Probability of bruise given ripe. So ripe is the denominator, 0.12. Bruised and ripe is the 0.019. You get this decimal. Or you could have used the table, right? Probability not bruised, right? Not bruised would be all the way at the total here, 0.946. So the purple was given to us and then just filled in the table. The green is what was filled in after the purple was given. B, which is larger, probability of bruise given ripe or probability of bruised. Well, bruise given ripe was the 0.158, and the probability of bruise was this 0.054. So the probability of bruise given ripe was greater than the probability of bruise. So given that they're ripe avocados, so it tells us that ripe avocados are more likely to be bruised than an avocado in general. Independent, the 3 ways of testing whether or not they're independent, no matter which way you did that, they're the decimal. So just compare your decimals. They should match up with one of the 3 ways here. But in either case, no, they're not equal. So they're not independent. And D is using the hypothetical 1000 table. Probability of bruise given not ripe. Given not ripe is 880 is the denominator. And bruised 35 out of 880, which is approximately 0.04.